Exponentials are much different than polynomials. Now we have, instead of a variable being raised to a number like x squared, now we have a number being raised to a variable, say 2 to the x. When x is greater than 0, and whole numbers, and even non-whole numbers, it's a little weird, but this is sort of like multiplication. Like if x is equal to 3, then we just 2 times 2 times 2. If x is less than 0 and we have negative numbers, then this is like a repeat division. The reason for this is because when we have 2 to the negative x, that's just the same as 1 over 2 to the x. And if x is 3 or negative 3 in this instance, then that's just 1 over 2 cubed, and that's just 1 over 8. Exponentials typically grow much faster than a polynomial. For example, if we had to compare x squared versus 2 to the x, let me just, and we plug in values, say x is equal to 3, 5, and 10. This is 9, 25, 100. Now this 2 to the x one gets a little tricky. First it starts off a little slower because 2 times 2 times 2 is 8. Now this is 2 to the 5. That's still not that bad. That's just 2 times 2 times 2 times 2 times 2, and that's 32. 2 to the 10 is still not too terrible, but it is a lot of 2's, and it ends up being 1024. And just with going up to 10 numbers, it goes up insanely faster. This is already 10 times higher. Now, if we go to a negative number now, let's say we do -3, -5, -10. These are still positive, so polynomials are still going to have that same shape where it's that U shape. Whereas exponentials are going to dip off. So as it goes larger and larger values, this one is going towards 0, although it will never actually reach 0. It'll look something like that, the graph. Although this would be 2 to the x and 2 to the negative x. Two to the negative x would look something like this. It's just flipped around the y-axis. Exponential functions show up all over the place. For example, in finance, the compound interest formula shows up. So A is the accumulated amount. the amount that we're trying to find. I guess it could just also just be amount. The P is the principal. The R is rate of interest. Typically like 2%, 5%, 10%. It's never going to be like a whole number. Well, less than 1 is what I should say. T is the time. Could be months, years, any form of time, really. And M in this instance is the number of compounds per time. And let's say if we have, I'm just going to rewrite it again. If we invest $1,000 at 2% interest compounded quarterly for 1 year, we can plug this in and write this as a formula. Let me just erase that actually. And this ends up being around $20 just for investing your money into the bank. If we change that to 2 years, it's still the same formula, except now we raise it to the 4 times 2 power, and this ends up being 1040.71. So, around $40 just for investing your money. Although that doesn't seem very great. The more you put in, the higher the principal, the more of a payout you will get. This is just one example. Other typical examples would be like a population growth. That could be like, number of people in a city, or bacteria, radioactive decay, even like other cool stuff, like apparently how objects cool, and photon absorption in a material. There's so many applications of exponential functions. Anyway, thanks for watching. Let me know if you have any questions.